This is a recording of my speculative design project presented on the 12th of the 4th, 2021. So for this project, I'm speculating a system that replicates the information feed from a virtual bike race into a real world setting for amateur bike racers. And I'll provide some context for that shortly. In terms of describing where it sits in the future cone, it's a relatively it's technology that could happen quite quickly, possibly over the next 1 to 5 years. So where we are now, within a year, I think it'll be relatively easy to hack or combine existing technology to make a minimum viable project for testing, so in a test setting. But having a plausible working system up and running would possibly take place in the next 3 to 5 years in a professional setting, and then be available for ubiquitous use in an amateur setting within 5 to 7 years. So just to provide some context, I'm calling this project sort of bringing the inside out, and it really comes from what's happened with bike racing in the last year and a half with COVID. And there's been a massive shift amongst amateur bike racers to using online platforms like Zwift, um, to an RGT to do bike racing indoors using virtual systems on turbo trainers. And what's happening now is people are migrating back with the end of COVID and the end of lockdown into real world bike racing, but with the expectation that possibly they might have the same kind of data feeds. And I think that's an interesting aspect to explore in terms of speculative technology. So this is a very simple triptych narrative about who amateur bike racers are, and just to narrow the story or the narrative down, I'm focusing on amateur racers at quite a high level, and in this case, female racers. So the who is like female racers who are engaged in amateur racing in Ireland. That's some elite level bike racers from my own club. Where they're racing is right now, in terms of COVID, they'll be racing off road in dedicated bike tracks. Corky Park is a classic example in County Dublin, but also in places like Mondello, so away from traffic. And in terms of speculative technology, we'll imagine that that's where they're still going to be racing, or on closed road circuits. How or what the system lives on, primarily it'll be on heads-up displays in advanced like glasses with some kind of projection device or peripheral eye tracking technology, but also integrated within the recording data systems that exist already on bikes, so power meters, heart rate monitors, and GPS. Um, this project didn't require a lot of research, but just in terms of informal research, I think in forming a picture of the persona of a female bike racer, typically very competitive, dedicated, and highly motivated, even though it's an amateur sport. They adopt a very professional approach. But safety is always top of mind because it is a dangerous sport. So hazard mitigation is always something that people are interested in. And those are a couple of shots of the kind of size of groups that would be typically racing together. So you can often have up to 100 people in very tight and technical circumstances. And that's the aftermath of a crash at Rostamon. So just defining a problem statement. Strategy in amateur bike racing is largely based on experience and instinct, even though you may have certain access to technology around your own power data and speed and position. Really, it's about experience, and doing well is often based more about on your own instinct and good feelings and experience than it is on necessarily fitness or power. So the challenge is it possible to use shared data in an amateur bike race to improve race outcomes? So to help develop the narrative, I've created a story around one persona. So this is Martina, is an imaginary elite level amateur bike racer. In this story, she's been racing with her local cycling club, the UX Wheelers, since she was 16. She's now 25, and she races at a very high level across the country with her club team. During the COVID-19 lockdown, she started taking place in virtual races on Zwift. This has allowed her to maintain her racing fitness and keep training, and enjoy the competitive aspect of racing, but indoors and away from the possibility of spreading COVID-19. And so she could stay in touch with her teammates and her competitors. So she really enjoyed the level of information Zwift provided and the dynamic of virtual racing. That's a screenshot of the interface, so it gives you a lot of data on your competitors. You can see them around you, but you can also see uh, the power that they're putting down as they're cycling, which is very interesting. And you can also see their exact position in front of and behind you. You can change your viewpoint, but also you can see a little inset map up there in the right hand corner about where you are in relation to the general peloton. You can see your own heart rate quite clearly, and then the duration of how much is left in the race, your own speed, and the gradient of upcoming hills as well, which is very interesting. So being able to have an overview of the race dynamic was really useful from Martina's point of view. And there's a little quote from her: "I'm surprised by how much info I can track, even when I'm pushed to my limit physically." So it might seem like a video game aspect of this, but it's actually very intense. The races are very hard fought, and as difficult as real races, although without the technical aspect of having to corner or deal with road surfaces or hazards. So with the rollout of vaccinations, it looks like the race season might start again soon, and Martina's club are entering a team for Rostamon. Rostamon is a 3-day women-only stage race that attracts a lot of the top amateur teams in Ireland, the UK, and across Europe. So it's a very prestigious race to take part in, and even more so to perform well in. Um, so in terms of speculative technology, what I'm saying here is that the UCI, which is the governing body, has recently given teams permission to use an interesting technology in amateur races. In particular, we're calling it the Insight system. So Insight allows team members and other race participants, if they wish, to share data about individual power, data, heart rate, and position on the course with each other during the race. So Insight, race data when you need it. A little bit of branding there. It allows racers to flag other participants as team members or competitors, and allows them to track their relative position and power output during a race through the interface of a heads-up display. It also flags turns, technical sections on a course, and distance to the finish. So this is a very quick mock-up of how the interface might work, and the visual interface or the visual aspect of it, although there may be haptic feedback as well, so you may and audio feedback. Um, so you can see customizable data fields on each side of the display. In this case, power, competitor power, your own power, and then sort of a connecting graphic that would show you how much effort you have to put into a match or beat them in the power output. A change of direction or hazard indication directly in front of you. And then in your peripheral vision, rider proximity and power status. So a little sort of icon-based system, which would be customizable to identify, proximity of competitors or teammates or neutral participants, if you like. And then also whether their power has changed. So you might get a flag if somebody's about to sprint past you or has increased their power dramatically. And then all that user interface would be customizable in advance. So you could, depending on who's agreed to take part in this system, you could give the different color codes, different icons, depending on your own preference about what's intrusive visually and so on. So the Insight system combines a number of existing technologies that measure data gathered about a rider during a race. So those I mentioned earlier: parameter, heart rate monitor, GPS for position. And we're combining it with a speculative technology that would collate all that data, interpret it, and disseminate it from a larger group of riders in real time. So back to the user story. Martina and her team are excited to try the system and will be in touch with their local teams about sharing their data during the race. The team's strongest rider, Catherine, is a favourite for the race, and Martina and her teammates will be riding all stages in support of her. So going into the race, they're very confident, and they do really well in the first 2 road stages. Each race is hard fought, but Catherine is well ahead in the general classification, which we call GC. And after the penultimate race, which is the time trial, she's sitting at the top of the league, and hopefully they'll do really well. So going into the last stage, the team need to do a couple of things. They need to ensure that Catherine gets a top 5 in the last race to win overall, and Martina's job is to, as a support rider, to cover any breaks by competitors, and in particular make sure that nobody gets away on the biggest hill of the course in the last race. So it's expected to be tough. And another quote from Martina: "It's a tough race and very tactical, but they're always looking for ways to improve, and they're excited to see if the inside system will give them a competitive advantage." So, this is a graphic representation of how the interface might look from Martina's point of view. So we're looking through our eyes through the heads-up display, her visor, her smart visor. So on the first lap, inside flags a tight corner, and coming up, you can see the hazard display on the top there, the position display on the right, and then Martina's own power on the left. So coming into the corner, we can see a little icon representing a narrowing of the road, which allows Martina to take a good line, and the competitor in front of her on her left actually goes into the cones, and Martina can move past her and then cover an attempted break by the rider up the head, who's, you can see there, ahead of her. So the quite technical course, but she manages to get right on her wheel, and she was a good catch on that corner, nearly went into the ditch. So then later in the race, the same rider attempts to attack on the hill, which is one of the significant points in the race where things can happen. The rider manages to get a little bit up the road, but using her visor display, Martina can track her power. So the system, it's an AI system. It knows that there's only 2 riders really close together, and it starts to match their power. So Martina can see she's doing 3.9 watts per kilogram, while her competitor is doing 4.5 up the hill, which is quite a significant amount of power. So Martina knows, okay, I need to really put the power down here to get on her wheel and make sure she doesn't get away. If she gets to the top of the hill and away, she has the potential to win the race. So Martina can use the system to match her competitor's power, and she gets on her wheel. Slight gap there going into a corner, but then Martina can see that her competitor, who's in front of her, is actually beginning to wane. Her power is dropping a little bit, and Martina can put the extra bit in, and then overtake her and block her going into the hill. So she really had to work, but she got there in the end. So towards the end of the race, 2 riders have escaped up the front, but they aren't a particular threat to Catherine's position. Remember, Catherine just needs the top 5, so Martina doesn't chase. Instead, she remains at the front of the lead chasing group, and she can see through her heads-up display that Catherine is just behind her, going into the last 500 meters. So she's able to maintain her position and cover a potential threat as somebody going into the last 500 meters. So hopefully this video will play. So there's the rider offers a potential threat going around the corner and into the last 500 meters. The system flags that they're in the last 500 meters to the finish line. So Martina can see again that she has to match the power and just really just stay on this girl's wheel. She knows Catherine is behind her, the second green icon on the right, and then really match that power up until Catherine, who's right behind her, decides to use her wheel as a launch, and she launches her own attack there on the right and powers ahead to take the win. So you can see Martina just drops her power. Then at that point, she's done her job. Catherine's fairly guaranteed that she's going to get the place, and then Martina cruises home over the last 50 meters. Still taking 4th though, which is pretty good. So job done. And a quote there from Martina: "We controlled that finish perfectly, but I can't help thinking that it was all a little predictable." So that was the story, the narrative, and just an examination here of the pains and gains that are addressed by the system. Pains, and something that might come up, is that an argument that the system does dilute the spontaneity of bike racing. It's a chaotic and spontaneous sport, and taking some of the guesswork out of it might actually ruin some of the enjoyment of it. Other pains, barriers to sharing data. Why would teams necessarily do that? It's a question that needs to be answered. It's an expensive system, likely to be an expensive system. And then there's an argument to say that it adds complication to something that's supposed to be simple and pure, like any sport, possibly. In terms of gains, it's definitely easier to make a strategic decision in a race, as we've seen in that little story. And there's a lot of clarity around the team's positions and competitors' positions. A big thing I think a lot of people would find attractive from a user point of view is hazard identification and improved safety. So there's always an issue in amateur racing. And the lack of closed roads, for instance, means that you're constantly have to be on the right side of the road, obviously, but then just very simple things like potholes, slippery roads, tight corners can have a huge impact on the safety. And then a massive gain as well is in the continual professionalization of amateur sports is the post-race analysis. So you have access to large data sets, which would be really interesting to see how things can be improved. In terms of ethical implications, some things to consider. Privacy is a huge one. So large data sets would be generated by this kind of system. So how do you know your own personal information is secure? It's definitely or possibly open to hacking. And then a question of, again, like anything that involves large data sets, who has access to data, who owns it? Access to the technology itself is something to consider in terms of ethics. So level playing field can only be maintained when there's equal access to technology. Um, Within the sport of cycling, this is a pretty grey area as typically competitive advantages gained through technology generally represent quite small gains. We've seen the adaptation of carbon frames. That's pretty ubiquitous now. But they were quite expensive at the beginning. But the gains that they actually gave were quite small, really, at the amateur level. So there's quite a lot of talk about it. But if you were good, you were good, regardless of the bike. That said, the technology described is likely to be initially expensive, and the cost may be prohibitive for amateurs. And then there's always the issue of cheating. The system, as described, is entirely trust-based, but with each individual accepting that the data is shared as legitimate. But there's a long history in this sport and in lots of sports of individuals and teams trying to game systems. So doping, use of technology, etc. So there's no reason to assume that the system wouldn't be a target of cheaters. Future work, if I was to develop this further, there's really three things that need to be looked at, and they are research, research, and research. Um, uh, Technology solutions is something to be examined in detail, and looking at UX and high stress environments, and then again how UI solutions in high stress and limited vision environments. Also, something I haven't really done at all in terms of this project is examine sports psychology. So, gathering insights into athlete behavior in high stress environments. And I think there might be an opportunity to collaborate with the sports psychology certificate in IADT there. And then just from developing a product point of view, the market viability, is this kind of something that anybody would really be interested in buying or working with or developing? I would say similar systems are almost certainly in development, and so finding out if there's possible competitors or collaborators within industry. I'll move on to the next set of slides, which are to do with the UX strategy project. So just to define what the ideal outcomes are for the project in terms of UX strategy, it would be a working system that could be developed for the marketplace, and then some subset outcomes. So a process that had the maximum output, again, a working system that has been robustly tested in the field with minimal input. So having a small, lean team and a minimal financial investment, so less investors, basically more value for the development team. And then a minimal time investment. I think, as I mentioned earlier, almost certainly people within sort of the technology ecosphere around the sport are developing similar things, I think, or I would imagine. So moving fast to develop working testable prototypes might give us a market advantage. There are a number of areas to focus on in terms of challenges. The technical challenges are significant And that's just a few of them: AI accuracy, device awareness, real-time situational awareness, and size and weight of working prototypes. There are very significant user experience challenges, including input points, uh, parsing what's important to know, and the volume of information and in a chaotic and stressful environment. And the UEI challenges, which I mentioned earlier, including obscurity and opacity, perceptual limitations, and then the technology limitations. And examining field of view issues, so the physical size of visors limits the volume of information, you're confined to peripheral views, and the comfort of all that. Then, finding a right balance around the volume of information in terms of distraction, constant change, and control of view. And then there's a significant cultural challenges within the sport. So as mentioned earlier, lack of spontaneity, unfair advantage, no longer playing field, perception of adding to risk, and then the distrust of change. So in terms of UX strategy and product strategy, I would be proposing to adopt a lean approach to product development. And that's just a very simple diagram illustrating the lean iterative approach of building, measuring, learning, and iterating again. So I've tried to outline some steps towards designing and developing the project in a lean framework. So step one is develop a project strategy. Step two is define and recruit an initial product development team, whose role then would be to do a fine-grained product strategy focused on building a minimal viable project for testing. Step four would be an iterative cycle of minimal viable product build, test, iterate, examine, and then further develop until you have a viable product that you can review from a product strategy point of view. And at that point, you would develop modular subteams, or you define what those modular subteams would be about, and then recruit them, and then move to the next step, which is product strategy phase two, which is the focus on a production level prototype. So building the initial product design team, I've just tried to outline here. It's a module sort of system where you'd have a core product team lead who would provide oversight and direction. And then working with them would be a project manager to kind of collate and gather all the learning and manage the tasks, a UX researcher, and a sports psychologist working very closely together with a UX designer, and then a developer and an engineer and or industrial designer. So that team's goals would be, as I said earlier, to define product strategy based on those key challenges, create a high-level product design brief based on our lean UX canvas, which I'll explain in the next slide, define timelines, they would define the key performance indicators, and later in the process then define further required expertise and individual team specs. And in all of that process, they would act as the operations team, so keeping the whole process moving forward, and report to the overall organization and all the other teams about progress. So I filled out a lean UX canvas just to kind of illustrate some of the key points that would have to be addressed in terms of the business problem. So the business problem is the design UX speculative design challenge. In terms of users and customers, initially I would say that we need to focus on early adopters and active amateurs who could act as influencers. And then I've outlined a number of hypotheses based on the solution ideas and what's the business outcomes, which are really interesting. So just to read out the hypothesis, not to go into all the details, so we believe that the integration of the system into race planning will be achieved if at least level amateurs experience firsthand the features of the system in a neutral race setting. In this slide, I've taken the modular development of teams and applied it to one team just to illustrate how that might work. So in the development phase of a lean process, the focus is on a testable minimal viable project for recycle of development. So what I'm suggesting is that we'd have integrated multidisciplinary teams focusing on specific aspects of the overall product. which is defined by the core product design team. So team members report back to their discipline team. So the software developer would report back to the general software development team during a daily scrum. So there's kind of high level communication of individual team goals. This team is focused on haptic feedback. So imagine haptic feedback notification for hazards as a concept. We do internal validation within the team. So the core team of UX designer, developer, engineer, stroke industrial designer, and sports psychologists would map out how haptic notification might work. And then a physical build of that within the MVP would take place with the UX designer, developer, and engineer. And then the whole team gathers again to test within a race setting, and they would learn from test racer behavior and then reiterate and report back their findings or integrate the findings of that aspect of the MVP into the broader MVP. How do we measure success in development cycles? Well, we'd have our key performance indicators as outlined by the team, but they might be timeline goals. So, we want to do all this within quite a short amount of time. We might have viability and test goals. So yes, it's working or it's not. It's a robust. Does it survive robust user testing? And then constantly tracking stuff like production metrics. So cost per test unit. It's difficult to do with very simple prototypes. But as you progress further along and increase quality, you could begin to sort of cost those out. And then at the end of this presentation, I've included two reading lists of articles primarily online that have informed my thinking throughout this process. And that is the end of my presentation.